Okay, next I'd like to talk how you are going to run the front ISTA. So this is the content of video 3. We would like to start with the flow of serial or parallel computations, and what kind of input files or what kind of input files for partitioning should be considered. So now I'd like to show what kind of inputs or how the sequential or parallel computations are carried out from the viewpoint of the users. So this is again shown in order to focus on the parallelization strategy. So you can see the difference of the sequential computation and the parallel computations. So if you are going to run a sequential computation, once you have prepared the finite element mesh of a certain domain, then just you can run the finite element method. Then you can obtain the displacement and the stress distributions. And when you are going to carry out the parallel computing, before you are going to run the finite element method, you need to divide a domain into subdomains, of which process is called partitioning. So you need to do the partitioning beforehand. Then once you have prepared the bunch of subdomains, then now you are ready for starting the parallel computation. And each subdomain, each computation of each of subdomain is taken care of by each MPI process. So from the viewpoint of the flow of the files, sequential computation would be like this. So you can see you have a front ISTA executable here. Then front ISTA is a kind of software, so you need to have a certain input files. And so front ISTA need to read three type of input files. So the first one is called general control file. And for this type of file, the name of the file is decided beforehand. You need to, you cannot change the name of this file. And the other two input files, the first one is a mesh file, finite element mesh file. So like number of nodes and number of elements, or coordinates of each node, or element node connectivity list, which can be also called the mesh subdivisions. Also the node group or element group can be described in this file in such a way that the boundary conditions can be easily assigned. And the boundary conditions or material constants or some computational parameters like selection of the linear equations, that kind of information is written in an analysis control file. And those two extensions of those two files are .msh and .cnt respectively. So in summary, so when you are going to run a sequential computation, what you need to do is to prepare these three input files and run from tester. Then you may get the computational results here. Okay. So let's look at the parallel computations. So as I said, before you are going to run the finite element computation, you need to do the mesh partitioning. So entire mesh is subdivided into the many number of subdomains like this. So, and input files for the partitioning tool, which is an independent utility, the general control file that is the same as before, HCMW control dot, and the finite element mesh file, of which extension is MSH. And also, this is a new control file called partitioning control file. And actually, this is a very small file. Just the information of the number of subdomains are included in this file. And the partitioning tool may run for these three input files. Then you would obtain the distributed mesh files, or subdomains are mesh files for many number of subdomains. Once you obtain the distributed mesh files like this, then mostly the same process of the sequential computations is now carried out. That is to say that you need to prepare the general control file here, and the distributed mesh files, and the analysis control files. Okay. Then from tester would run on a parallel environment, and the results are also distributed, but we are offering some utilities which is called R-merge, in such a way that the computational results are merged into one domain mesh, one domain result. Okay. So from now, some examples of each input files are shown. This slide shows typically the general control file. Actually, this is here. Only the name of the input files or its directory paths of the files are described in this file. So the size of the file is quite small. Okay. And the second file, .msh mesh files, are like this. So the first part includes the coordinates of each node, and the second part is the element node connectivity. For instance, it's number of element is composed of these number of nodes like this. So then These two informations shows the mesh information. So the other part, for instance, is node groups or element groups information are defined in order for the boundary condition can be easily assigned. Okay. This is the third or last input file, analysis control file. So a couple of information is included, like value of the boundary conditions or material constants or some other computational parameters. For instance, it's what kind of linear equation method or linear equation solvers should be selected, or what kind of preconditioning is used, something like that. Okay. So the last one is the partitioning control file, or excuse me, this is the general control file for the parallel computations. So if you are going to carry out the parallel finite elements, you need to specify some information about the partitioning tools. Okay, so we have to consider a small difference of the general control file between the sequential and the parallel computations. Okay, and this is the partitioning control file. When you are going to subdivide the finite element mesh into some subdomains, you need to run the partitioners, and the partitioning control file is required when you run that utilities. And it's quite small input file. The important information is the number of subdomains. So in this example, it says you need to divide a domain into 4 subdomains.